day students, welcome to math.serve.com. In this clip we're going to be going over problems 30 to 34 of the Algebra 2 Common Core New York Regents exam for January 2017. Alright, let's take a look at question 30. It reads, given the equal terms, the third root of x to the fifth and the 5/6 root of y, determine and state y in terms of x. Okay, so what we're going to be doing here is basically expressing y as a function of x, basically getting y by itself. Okay, before I do that, let's go over one formula that's going to guide our problem solving process. Okay, and this is the fractional exponents property. Fractional exponents property. Okay, so fractional exponents property. Okay, so the fractional exponents property basically states that if you're taking the mth root of x to the nth power, this can be written as x to the power becomes the numerator of the fractional exponent, and the root is the denominator of the fractional exponent. Okay? Now, one side note that you want to keep in mind, to state y in terms of x, what does that mean? We indicated that earlier. To state y in terms of x means to solve for y. That's what it means. Okay, so let's go ahead and equate these two together and solve for y since they're equal terms. So we have the third root of x to the fifth power equals y to the 5/6. So the goal is to get y isolated. In order to isolate y, we need to get rid of this power, the 5/6 power. Now, to ease our problem solving process, how about we express both as fractional exponents? Using the fractional exponents property on the term on the left side, we can express this as x to the fifth. Now the root becomes the denominator of your fractional exponent. Okay, and that is equal to y to the 5/6. Now, what is the inverse of raising a term to the 5/6 power? The inverse of that operation is to raise the exponents to the reciprocal of that power, and that will accomplish the inverse. Okay, so since we're raising this to the 5/6 power, if we raise it to the power of its reciprocal, 6/5, we are going to accomplish the inverse operation. What does the inverse operation do? It basically eliminates what this power does. If you multiply this out, what do you notice happening on the right side? The 6's divide out to 1, and then the 5's divide out to 1. Okay, so we now have x to the, now we can, let's just multiply this out. 6 times 5 is 30 over 3 times 5 is 15 equals y. So it follows that y equals 30 divided by 15 is 2. And this is our goal because we have isolated y by itself on one side of the equation. So this is y in terms of x. Okay, let's take a look at question number 31. It says the results of a survey of the student body at Central High School about television viewing preferences are shown below. Question: are the events student is a male and student prefers reality series independent of each other? Justify your answer. Okay, so let's go over the formula that's going to guide us through this problem. This formula, we're going to call it the test for independence. Okay, test for independence. Now, how do we know that two events are independent? Let's call them events A and B. Okay, so events A and B are independent events um, if and only if probability of A given B is equal to the probability of A. Okay? Or you can write it this way: probability of B given A is the same thing as the probability of B. If you have a situation like this, then the two events A and B are independent. Okay? So in this particular problem, there are two ways we can solve this problem, depending on whichever one you want to pick as the first one, and then the other one will be what is given. All right, so let's start by stating what our events are. Okay, so let M be the event that the student is a male. Okay, student is a male. And let R be the event that the student prefers what? Prefers reality series. Okay, so what we're going to do is we're going to carry out the test for independence. Okay, is the probability that the student is male, given that the student prefers reality series, is it equal to the probability that the student is a male? Is this true or false? If this statement is true, or if they're equal, then the events are independent. If they are not equal, then they are not independent. Okay? So let's start with probability of male. We know what probability is. Probability is basically successes divided by the total number. Okay? So let's do the setup on the side, and then we're going to input it into the formula. So what is the probability that the student is male? This is basically the total number of males divided by what? The number of students. That's the probability that a student is male. Okay? Probability that a student is male, given that the student prefers reality series, we're just going to look at the number of male students that like reality series and divided by the total number of males. All right, let's move it to the right a little bit to make some space. So probability of male given reality series is number of males that prefer reality series divided by the number of males. So these are the two probability setups that we're going to be looking at. Okay, let's start with probability of male given reality series. So we're looking at number of males that prefer reality series. Right here, that's 70 divided by the total number of males. So probability of M given R is going to be 70. The number of males that prefer reality series divided by the total number of males, which is 180. The question is this equal to probability of males is the total number of males. Total number of males is 230 divided by the total number of students, which is 490. Probability that a student is male is 230. Number of males divided by the total number of students, 490. Okay, so just simply compare these two quotients and see if they are equal. Okay, so 70 divided by 180 is 3.8 repeating, so 0.38 repeating. Is it equal to 230 divided by 490? Here we have 0.469. So this is 0.469. Are they the same? The answer is no. So this is false. Okay? They are not equal. So since they are not equal to each other, then that automatically means that the events are not independent. Okay? So let's go ahead and explain what we just did and write the conclusion. So the conclusion is that the two events are not independent are not independent of each other. What's the reason? Because the probability of the first given the second, basically the probability of the first given the second, we're looking at the probability of males given that they prefer reality series. Okay, the probability of the first given the second is not equal to what? Is not equal to the probability of the first. Okay? You can use first, second, or you can say, you can specifically state what the first and second events are. So you can say that the probability of males given that they prefer reality series is not equal to the probability of a student being a male. Okay? Since those two probabilities are not equal, the conclusion is that the two events are not independent of one another. Alright, let's take a look at question 32. It says, given f of x equals 3x squared plus 7x minus 20, and g of x equals x minus 2, state the quotient and remainder of f of x divided by g of x in the form q of x plus r of x divided by g of x. Okay, so let's go do a real quick review on the vocabulary of finding the quotient of rational expressions. Okay, so recall, if you have a polynomial f of x divided by g of x written in the form q of x plus r of x divided by g of x, then we have the following keywords you want to keep in mind. F of x is the what? F of x is the dividend, expression. G of x is the divisor. That's what you're dividing by. That's the divisor expression. Q of x is the Q for what? It is the quotient. Okay? And then we have r of x. You might have guessed what it is. R of x is the remainder term or expression. And we already have g of x as the divisor again. Okay? Now to solve this problem, we're going to approach it using two different methods. Okay? The faster method is something called synthetic division. It's very good when you're dividing polynomials where the leading coefficient of your first degree polynomial divisor is 1. Okay? If the leading coefficient is 1, it's very easy to use synthetic division. So let me show you that method real quick. So method 1. That's synthetic division. After we do that, we will go over the long division method. Now, synthetic division is very, very powerful when you're dealing with polynomials with a lot of terms, okay? As opposed to long division, it takes a while. Okay, so we have g of f of x equals 3x squared plus 7x minus 20, and g of x equals x minus 2, okay? Alright, so to set it up, we're going to put up our synthetic division bars, which is basically like an upside down long division. And then we'll extract the coefficients. Okay, we have 3, 7, and negative 20. Now we're going to find the 0 of the divisor. Okay, so you set x minus 2 equal to 0, and then you solve, you get 2. So put the 0 out here, which is 2. And then what you do for synthetic division is you add downwards and multiply across. Starting with a 0 here, you add down. 3 plus 0 is 3. Multiply across. 2 times 3 is 6. You add down. 7 plus 6 is 13. So we have 13. And then we'll multiply across. 2 times 13 is 26. You add down, you get 6. Okay? So you draw your line here. This is known as a depressed polynomial. Since the degree of the divisor of the dividend polynomial is 2, the depressed polynomial is going to have a degree that's 1 less than the dividend polynomial function. Okay, so our answer is going to be 3. This is x squared, so this is going to reduce by 1 because we divided out by a factor, x minus 2. So we have 3x plus 13. Your remainder is 6, written in the r of x over g of x form. You write plus 6 divided by the divisor, x minus 2. Okay, so there goes your answer. Now, you might not really see how powerful or how quick this method is because we're dealing with just a trinomial, a quadratic trinomial. But if you have more terms, then you really see how fast and beneficial this synthetic division method is. Okay? Now let's go over another method, method 2, which is the long division method. Now the power of the long division method is that it can attack any kind of problem. It doesn't matter how weird the division of polynomial scenario is. You can always use long division. Okay? So that's the beauty of it. Although the downside is it's long and involved, and it's easy to make mistakes with signs and things of that nature. Okay, so let's do the long division. Just like we divide numbers regularly, you have the dividend, the divisor on the outside, and then we put the dividend on the inside. Okay, so the dividend polynomial f of x is 3x squared plus 7x minus 20. So all you do is you focus on the leading term of the divisor and the leading term of what you're dividing by. In this case, we're dividing by the entire dividend at this time, so that's what we'll look at. Okay, so how many times is x going to 3x squared? That's the question. Another way you can look at it is 3x squared times what? X times what gives you 3x squared. Okay, so just divide it. You say, okay, x times, there has to be a 3, and then since this is x squared, x times 3x gives me 3x squared. Okay, now you multiply out. 3x times x is 3x squared. 3x times negative 2 is negative 6x. And you're going to subtract. Okay, so you subtract. When you subtract, what happens is that you have an inversion of signs. So this becomes minus, and this becomes plus. Okay, so when you subtract, you add down, and then you're gonna have the first terms always have to cancel out. Okay, 7x plus 6x gives us 13x. And then you bring down negative 20 because since the divisor is a binomial, we always have to deal with binomials, 2 terms at a time. Okay, that's how you do it. Repeat the same process. X times what gives you 13x. X times positive 13 will give us 13x. Or you just divide 13x by x. Okay? Distribute back. 13 times x is 13x. 13 times negative 2 is negative 26. Okay? Notice how long and technical this process is compared to this synthetic division. And this method gets worse with the more terms you have, okay? All right, so we're going to subtract again. So when you subtract, what happens is that you're going to add the opposite of this term right here. So we're going to add the opposite, make this a minus, make that a plus. When you add it down, the first terms cancel out. Negative 20 plus 26. Subtract, keep the sign of the bigger, positive. So your answer in f of x in q of x plus r of x over g of x form is 3x plus 13 plus the remainder, which is 6, divided by x minus 2. So as you can see, both of our answers are the same. So whichever method you like, you can use to accomplish your goal for this particular problem. All right, let's take a look at question 33. It says, algebraically determine the values of h and k correctly to correctly complete the identity stated below. All right, so let's take a look at the identity that we have here. We have a cubic with 4 terms, and on the right side we have the product of a binomial expression with a quadratic trinomial plus k. All right, so what are we doing here? Well, what we're simply doing is we're going to simplify the right side completely, and then we will be able to determine what h and k are. Okay, so from the look of things, it looks like h of k is going to h is going to be the coefficient of the second degree term, and k is going to be a constant. Okay, all right, so all we're going to do, just focus our attention on the right side. So if we expand the right side completely, the right side of the equation completely, side completely, and compare. Just by direct comparison, we will be able to easily tell what the h and k values are. So what we're doing is we're multiplying x minus 4 times 2x squared plus hx plus 3, and then we'll add k after that. So we're multiplying a linear binomial with a quadratic trinomial. So I'm going to use the box method just to help me stay organized with my multiplication here. So, and then we'll need to not forget to add k at the end. Okay, so we have 3 terms here. All right, now the quadratic trinomial goes on top, 2x squared, h times x, hx, and positive 3. And then we're going to configure our linear binomial vertically, x and negative 4. Okay, so this is just a multiplication grid that we're going to simplify. Okay, all right, let's go ahead and multiply. So we have x squared times 2x is 2x to the third power. And then h of x times x is hx squared. Just multiply the x and the x, so hx squared. And then we have 3 times x is 3x. All right, so we're done with that. 2x squared times negative 4 is going to be negative 8x squared. hx times 4 is negative 4 hx. And then 3 times negative 4 is negative 12. All right, so let's go ahead and simplify. So we're going to have, we have 2x to the third, so it's going to be 2x to the third. And then we're going to combine this 2 terms right here. Those are our squares. So we have negative 8x squared plus hx squared. And then we have the next set. Combine these two. We have minus 4hx plus 3x minus 12, and let's not forget plus k. Alrighty. Alright, now let's go ahead and bring down the left side of the equation. So what's the left side of the equation? We have 2x to the third minus 10x squared plus 11x minus 7. Okay, so just by comparing, you can easily determine what the values of h and k are. So let's look at k first. Negative 12 plus something gives you negative 7. What do you add to negative 12 to get negative 7? If you add 5 to negative 12, you get negative 7. So you can easily see that k is your k value is going to be positive 5. And then if you look at the squares and you ask yourself, negative 8 times plus what gives you negative 10? Negative 8 plus negative 2 gives you negative 10. So just by inspection, we can easily see that k is positive 5 and h is negative 2. Okay? But we can also make it more obvious by combining like terms, simplifying our expression completely. Okay? So to do that, what we're going to do is move all the terms without h and k to the left side, and then leave all the terms with h and k's on the right, and then we can make a much more accurate comparison. Okay? So we're going to subtract 2x to the third, move that to the right, to the left, since it doesn't have any h and k's there. 8x squared, we're going to move that also by adding 8x squared to both sides. Move that to the left. What else does not have h or k? Oh, 3x. We subtract 3x from both sides. Does anything else not have h or k? Yes, the negative 12. You add 12 to both sides. Okay, now we're going to simplify both sides of the equation. Okay. When we carry out our simplification on the left side, we have 2x squared minus 2x squared. That just adds up to 0. Negative 10 plus 8 gives us negative 2x squared. 11 minus 3 gives us positive 8x. Negative 7 plus 12 gives us positive 5. Equals. On the right side, this is gone. That's gone also. We have hx squared. That's gone. That's gone. Minus 4hx plus k. So just by comparing the degrees, we have negative 2x squared is equal to hx. That follows hx squared, which follows that h must be negative 2, the coefficient of the second degree term. And then comparing the constants, we automatically have k is equal to 5. Alright, so there goes our answers. H is negative 2 and k is 5. Let's go ahead and box that. Alright, let's take a look at question 34. It reads, Eliana has decided to run the Buffalo Half Marathon in May. She researched training plans on the internet and is looking at two possible plans. Jillian's 12-week plan and Josh's 14-week plan. The number of miles run per week for each plan is plotted below. So we have the star plot for Josh and the linear plot for Jillian. Question. Which of the following plans follows an arithmetic pattern? Explain how you arrived at your answer. Alright, so one thing you want to keep in mind concerning arithmetic patterns is that the graphical representation always follows a linear pattern. Okay, so let's just draw a line on Josh's pattern right there, and then let's draw a line on Jillian's pattern right here. Which of them is linear? You can clearly see that Jillian's plan is linear. Okay, so what does that tell us? It tells us that the arithmetic pattern is Jillian's. Okay, the fact that it's linear indicates that there is an additive growth constant. In this case, by how much does it grow? For every week, let's say you're going from week 2 to week 3, it's going from 11 to 12. So it grows by 1 mile every week. That's the additive constant, or the slope of the growth pattern for Jillian. Alrighty. So let's go ahead and write down our answers along with explanation. So Jillian's plan follows an arithmetic pattern. So that's our answer. What's the justification? This is because the graphical representation, or the graphs of arithmetic patterns, are what? Are linear. Okay? They're linear, and only Jillian's plan follows a linear pattern. Okay, a linear pattern with what? With an additive growth constant, also known as the slope, with an additive growth constant of what? What's the slope? Additive growth constant of 1 mile per week. Okay, so you can state these two facts in your answer, or just state that it's a linear pattern, or you can state that there's an additive growth constant of 1 mile per week. Any of those combinations will be a sufficient explanation as to why Jillian's plan follows an arithmetic pattern. Alright, let's take a look at the next part of question 24. It says, write a recursive definition to represent the number of miles run each week for the duration of the plan you choose. Okay, so now if you take a look at both patterns, both plans, there are patterns manifesting themselves. If you look at Josh's pattern, you notice you go up 1, 2, right, and then down 1, and then you go up 1, 2, 3, down 1, and then 1, 2, 3, 4, down 1, and then 1, 2, 3, 4, 5. There is a pattern going on here. And then in Jillian's pattern, you just keep going on by 1. Okay, so which is a smarter choice to pick? We just pick Jillian's pattern, right? It's easier to determine what her growth plan is using a recursive definition. Okay, so there is a formula for recursive definition of arithmetic and geometric patterns. Okay, so let's go ahead and write down the formula. This is the formula for the recursive definition of arithmetic patterns or sequences. Alright, so the formula is as follows. You have to start with the A1. A1 is the first term. And then subsequent terms, we're going to call it an plus 1, will be the first term plus the common difference, whatever that is. Okay? Alright, so let's take a look at Jillian's scenario. What's her first term? What is A1? A1, if you look at the graph, on the first week she's at 10. Okay, so we have this combination right here. So A1 is 10. And we already indicated by how much it grows by. The common difference D is 1. Okay, that's a common difference in her intervals. Alright, so we have all the information we need to generate her recursive definition. So for Jillian's plan, we have to indicate which one we're doing. Okay, so for Jillian's plan, we have the following recursive definition. A1, the first term is 10. And then the next term is just going to be the previous term, A1. Or actually it's AN, so it's going to be AN plus the common difference, which is 1. Okay, so the common difference is 1. So an plus 1, the next term is going to be the nth term plus the common difference, which is just 1, starting from 1. Alright? Okay, so let's make a real quick correction to our formulas real quick. So the an plus 1 is actually the nth term. The nth term plus the common difference. Okay, so this is the recursive definition for Jillian's plan. Alright, let's take a look at question, the last part of 34, part C. It says Jillian's plan has an alternative if Ileana wanted to train instead for a full 26-mile marathon. Week 1 would start at 13 miles and follow the same pattern for the half marathon, but it would continue for 14 weeks as opposed to the 12 weeks illustrated on the graph. Question: write an explicit formula in simplest form to represent the number of miles run each week for the full marathon training plan. So here we are looking at the explicit formula for an arithmetic pattern or sequence. So we have a formula for that. Let's go ahead and write that down. Formula for the explicit formula for an arithmetic pattern or sequence. Okay, arithmetic sequence. Alright, so the formula is an, the nth term, is equal to the first term plus the number of terms minus 1 times the common difference. Okay? Alright, so for this new plan, what is the starting time going to be? Ileana will have to start, instead of starting at 10, she will be starting at what? 13. So A1 is going to be 13. How long is it going to be with this new plan? Instead of 12 weeks, it's going to be 14 weeks. So N is going to be 14 weeks long. But since we're looking for the nth term, in using this particular formula, instead of putting in 14, we're just going to leave N as N. Okay? Because we're looking just for an explicit formula. We are not going to plug in 14. Alright, and then the common difference is what? It grows by 1 every single time. So let's go ahead and plug that into our formula. So the nth term, an, we're not looking for the 14th term here. If we were, then we'll plug in 14. But if you're looking just for formula, just leave n alone. Okay? So the nth term is going to be a1, which is the starting term, plus n, just leave it as n since it's just a general formula, minus 1 times the common difference, which is 1. Okay, so we're asked to write it in simplest form, so we need to simplify this completely. We have an equals 13 plus, distribute this 1 across, plus n minus 1. And then we have like terms, 13 and 1, and negative 1. So your nth term is going to be n plus 12. Okay, so there goes the explicit formula for the nth term. What this basically shows you is that the explicit formula for the nth term is the same thing as the nth term formula for finding the same thing as the formula for finding the nth term of an arithmetic sequence. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study and your preparation for the Algebra 2 Common Core Regents, to give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comments section below, and we'll be more than glad to support you. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.